Hello students, I am Dr. Saliha Jamal, Associate Professor from Department of Geography, Aligarh Muslim University, Aligarh. So today's class is going to discuss with the topic that is types of spatial measurement with real world examples. As we have discussed what is spatial analysis and its types of spatial analysis in previous classes, if you remember students, in those types we have discussed there were 6 types of spatial analysis. In those 6 types, one of the type is measurement. So today I am going to discuss about the types of spatial measurement with real world examples. Although I have introduced what is measurement in spatial analysis, but today's class will focus on types of spatial measurements, and that too that will be explained with some of the real world example. So actually what does the spatial measurement means? When we talk about what spatial measurement, it simply means that quantifying physical space. We are talking about because in spatial analysis we know we are talking about space, spatial features, spatial objects, spatial phenomena. So here also when we talk about the spatial measurement then it means quantifying the distance between the spatial features, between the, we can say, spatial entities, maybe in terms of length, area, volume, angles, etc. So the term, whatever the term means, measurement in daily routine, or we can say in day-to-day parlance, we generally think measurements mean quantification of something. Here the something is the spatial entities, spatial objects. So it means it will measure, measurement in spatial analysis particularly means that we are going to measure, we are going to deal with the distance between the 2 points, or we can say between the point and the polygon, that is the area, or we can say simply quantification in terms of the length, area, volume or angles. So why it is very much important to have the discussion about this spatial measurement, why we include this spatial measurement? If we see, it is very much essential for accurate representation and analysis of the physical world. If we are not going to measure the length, area, or we can say the volume and angles, we cannot accurately depict the different spatial entities or object location on this surface, that is the surface of the earth. So for the accurate analysis and representation, it becomes very much important to have spatial measurement. It also helps us in decision making in various fields, that may be include in urban planning, because most of the things we are dealing here with the spatial units, that is the urban area. So measurements plays a very important role, not only in urban planning but also in architecture, engineering and environmental science. So importance of spatial measurement can be seen in various fields and various disciplines. When we talk about the conventional measurement, how the measurement was, or we can say the traditional approach in measurement was the modern approach in measurement, we will see traditional methods of measurement was generally we used to quantify or measure with tools like tape, or we measure with tools like compasses, theodolites. That is what we can say traditional approach or traditional tools for the measurement. But nowadays in this modern world, we have lots of modern technology, that may be GPS, that may be GIS, LIDAR, photogrammetry, that offer n number of capabilities for the spatial measurement. So from past to present, lots of differences have been seen in the use of tools and techniques for spatial measurement. So if we see the few of the applications of spatial measurement, it is mainly used in land surveying. If you remember, or you can say if you have heard, firstly the when we generally move for the field survey or all, we generally carry the theodolites, or we have the land surveying, plane table survey, different types of conventional approach to measure various things, maybe in terms of angles, maybe in terms of length, maybe in terms of distance between the 2 points. But now we can say we have lots of more advanced tools. Already I have discussed like GPS, GIS, LIDAR. These are some of the modern technologies which give very much accurate result, and its applications can be seen particularly in land surveying. You may also see in construction, maybe in resource management also, and maybe also in environmental monitoring and urban development. Actually, the spatial measurement plays very important role, not only what I have discussed in construction, resource management or and all, but also it plays a very important role in navigation and disaster management and scientific research. Navigation for finding out the routes, maybe in the shortest route, most convenient route can be said, or routes without the obstacle. For the disaster management, how to reach the particular site in less time. These all things can be managed through the measurement. Now, but while having the spatial measurement, we generally used to face lots of challenges. Although I have dealt few of the, if you remember in the previous classes, I have also discussed about the problems and challenges that we generally face in spatial analysis. But in particular, what are the problems we face, what are the challenges we face in spatial measurements are, that is maintaining the accuracy over large distances. Whether we will get more accurate results for the large distances, or for, we can say, most rugged topography, that may be said in terms of the various complex terrains also. And also the interpretability, we can say, is the which we have to ensure, where we have accurately interpreted the things or the entities or the objects, their measurements, etc. That should be very much accurate. Not only that, standardizing the data, we have to proceed. We know that we receive spatial data, we acquire spatial data from the lots of sources, and that due to the lots of sources, they may have some different systems of units, may be there may be some different projection and all. So when we integrate for certain planning or decision making, we have to proceed with the standardization of data across different systems. So this is also one of the very important challenge we face in the spatial measurement. And then another challenge is, that is the addressing the privacy concern, mainly related to the particular location data. For example, certain for the defense purpose, certain privacy is needed for, or any army activity, certain privacy is to be needed for the location data. That is another concern, that how we have to proceed with lots of data without maintaining the privacy. That is another challenge. Then managing the volume and the complexity of the spatial data. That is because we know there is lots of spatial data that is not existing now only, but from the past, if we see, the data were existing, voluminous data, big data are existing, but we have to use the usable information from that. We have to extract the information according to the set criteria or according to the need that is to be only used. This is also in the how to extract the usable information. For example, this can be solved through the GIS environment, working with the spatial data in the GIS environment. This can solve this problem to an extent. And lastly, I can say it requires continuous innovation and interdisciplinary collaboration to overcome all these changes, because we know data science, that does not it is not data science is not only the field that is used by a particular discipline, but it is a mainly interdisciplinary, because many times in its tools and techniques, geography is also involved, statistics is also involved, engineering aspect is also involved. So mainly the challenges which we generally face in spatial measurements, that is mainly solved through the innovations and maybe with the interdisciplinary collaboration. So these are the lots of challenges which generally we face during the spatial measurement. Now coming to the types of measurement, because we have dealt what is measurement, simply we can say quantifying the different spatial dimensions in terms of length, in terms of we can say area, volume, etc. So coming to the types of measurement, we can say there are different types of measurement that is based on the how we are going to measure, because when we are quantifying the distance from one point to another, that is a separate type of measurement. When we are dealing with quantification of the things in an enclosed boundary, it means different types of measurement is to be used. So accordingly we have different types of measurements. So coming to the different types of measurement, first type is Euclidean distance. We here go for measurement of Euclidean distance. What is Euclidean distance? Actually, we can say it is a straight line between two spatial entities, or we can say between two points in Euclidean space, because this class is mainly dealing with the real world examples where the spatial measurements are used. So we are going to have examples for each and every measurement. If we are talking about the Euclidean distance, suppose I have said what is Euclidean distance, simply the straight line between the 2 points in Euclidean space. For example, on a map, if we are going to have the straight line between the two cities, we can say that is the Euclidean distance. So the distance, for example, between the two cities, which is measured by a straight line on the map, such as I can give here example, that is the distance between the New York City and Los Angeles, straight line without getting inside the different network. So just having the measurement with the straight line from one point to another point in Euclidean space is known as Euclidean distance. Now coming to the great circle distance. Great circle distance is very much useful in navigation and all, because with this type of measurement we usually find out the shortest distance between the two entities or spatial features, or we can say that we find out the shortest distance between the two points on the sphere, on the surface of the sphere, or we can say curvature of the sphere, because we know earth is sphere, earth shape is mainly it is a spheroid, we can say. So here we can say that the finding out the shortest distance between the 2 points on the surface of the sphere, which is generally measured along the curvature of the earth, or we can say curvature of the sphere, rather than going interior. Interior means we are not talking about following the different inside intersected here networks or the pathways, but instead we find out the shortest distance between the 2 points on the sphere, we can say simply on the surface of the sphere. If we take example for this great circle, the example here which I have quoted, that is the distance travelled by an airplane between the two airports, like we can say any two airport between JFK International Airport and Heathrow Airport. So simply the distance travelled by an airplane between the two airports. So that is mainly the great circle distance. Coming to the third type of distance, that is the travel distance. Travel distance, this even we also use in our day-to-day life, that is the travel distance, that is traveling along a specific route, considering several types of road network, what should be the transportation mode in particular road network, and what may be the possible hurdles or obstacles. Obstacles in terms may be seen in terms of the traffic congestion, maybe the obstacles in terms of the bad road, bad network and all. So actually simply this travel distance concept, what I am going to explain here, we also use in our day-to-day life for traveling from one place to another. So travel distance is actually the distance travelled along a specific route, considering the different types of road network and the transportation modes, and also the what will be the different types of hurdles or obstacles in that particular road network, that is also to be considered. If we are going to give example, I would like to quote here: calculating the distance and travel time, because whenever we also go anywhere, we plan to go anywhere, we usually see on Google map what will be the distance between that point from where we are starting and what is our destination, what is the distance. After seeing the distance, we usually see what are the different road networks or different routes through which we can reach our destination. Then we used to see in what time we are going to reach that destination. So first we see the distance, then we see the different options of the routes to reach the destination, then we see how much time it will take to reach the destination, and what may be the hurdles. Maybe a shortest route may have the obstacles like lots of traffic congestion, or maybe the roads are not good, or maybe if we are on road trip, we require petrol. If that maybe certain route is lack of petrol pump, so no, we will avoid that route. So these are the things we usually consider all together to travel from one place to another. So example here is the calculating the distance and travel time for delivery truck to reach the destination on a road network. It has to reach the destination, delivery truck to deliver certain goods, we can say. So that will also be taken considering the travel distance. Or we can say the distance traveled by the courier from the distribution center to the residential address, that is also will be considered under the travel distance. So all these examples which have been illustrated here is having the diverse application of distance measurement methods that can be seen in various fields, maybe in geography, transportation, maybe in planning, or maybe in logistic management. So first one, here we have discussed distance measurement. Now we are going to discuss another type of spatial measurement, that is area measurement. And what if we talk about the area, here we are dealing with the quantifying the size of two-dimensional surface, maybe in terms of the length and breadth. So here actually we are quantifying the spatial entities or objects having two-dimensional surface, and it involves calculating how much space is being enclosed within a certain boundary, or we can say within a certain shape. How much space is enclosed, because in previous slides I have explained, when we are talking about the spatial measurements, we talk about the length, area, volume, and all the angles, these things. So if we are talking about the area in which quantification of size of any two-dimensional object, where actually we quantify the amount of space that is enclosed in a particular boundary or shape, maybe as in polygon, maybe circle or irregular land parcel. How much space is enclosed, whether in a polygon, whether in a circle, or any types of land parcel. So this is the area measurement, and which has different types of measurement. Just like we'll start n number of measurement like numeric attribute, categorical attribute, ordinal attribute. We will discuss one by one now. First one is numeric attribute, as the word numeric term is suggesting here. So here we are quantifying the values mainly in quantitative terms. So numeric attributes represent quantitative values that may be measured in count within a given area. And we have to give example, because this class is particularly to explain the different types of measurement with example. So when I am talking about to represent the quantitative values that can be measured in terms of count in a particular area, for example, calculating population density by the different census tracts in the city. The population density will need the population count and the area. So it will involve dividing the total population by the area of the parcel of land or tract, even we can say, that is dividing the total population by the area of each tract in order to obtain the people per unit area or per square kilometer and all, what we can say. So, this is what we can say numeric attribute. Simply numeric attribute, it represents the quantitative values in terms of count in a given area. An example can be taken as population density. The second one is categorical attribute. The term here you see, that is a categorical category. It means we are representing category, we are representing the attributes in different classes. Best example for representing the categorical attribute is representing the qualitative classes, because previous one in numeric attribute we have the quantitative values, but here it will have the qualitative values, qualitative classes, because it is categorical in nature. The best example you can take here, the land use type within a region. Maybe the land use type, we are now going to give a class or category. The land use type may be residential, maybe commercial, maybe industrial, maybe agriculture, maybe recreational, etc. This means we are giving the categories, classes, categorizing. So, this is what we can say categorical attribute. Now, binary attribute, again, just students think with the words. Many times the word itself explains various things, because when we talk about the binary, the first thing come in our mind, binary, something two. So, here the attributes have only two possible states, only two, not multi, not single, only two possible states or two possible categories, that in the terms of present or in the terms of absence. Means here we are following only the binary attributes having two states, to its either presence or absence of a certain characteristics in a given area. Because why we are talking about the area, we are here dealing with the area measurement. So, any of the two categories, present or absence of any characteristics in the given area. Example, mapping the presence of particular species within a certain habitat or conservation area. It means what will be the result? Either the particular species is present or absent. So, simply mapping the presence or absence of particular species within a certain conservation area or within any designated habitat, and this is very much important for biodiversity conservation and habitat management. Now, coming to the fourth type, that is ordinal attribute measurement. When we talk about the ordinal attribute measurement, here the ordinal attributes represents ranked categories within a given area, and that ranking may not be uniform. It is but obvious when we are talking about the rank in simple terms. First, second, third, fourth. It means where the differences between the categories may not be uniform. A student who is first in class and who is second in class and who is third in class, the difference between their marks may not be uniform. In the same way, here we can say in ordinal attribute measurement, here the representation of attributes is in ranked categories. For example, assessing soil erosion severity, ranking in terms of low, moderate or high erosion rates. Here just we have ranked the areas having the low erosional rate, medium erosional rate or high erosional rate. That is what we can say. We are dealing with the ordinal attribute measurement. Now, the next one is nominal attribute measurement. Nominal attribute represents categories with no inherent order or ranking within a given area. Means it represents categories. Attributes are represented in terms of categories but without any inherent ranking or order. For example, no ranking is there, although there is category, but there will be no ranking and no order. What we have seen, just like in ordinal attribute, there is a particular ranking. So, here we are not going to give any ranking, any order, just we are going to categorize the attribute. For example, classifying types of vegetation cover within a particular forest ecosystem. So the vegetation cover may be the deciduous trees, maybe the coniferous trees, maybe shrubs, grasses, herbs, etc. It means here just we are categorizing, we are not ranking, and we can say even we are not giving the particular order. So these categories are mutually exclusive and do not imply any order, we can say. So this is what we can say nominal attribute. Coming to the temporal attribute measurement, when we talk about the temporal attribute measurement, here we are dealing with the time attribute, means we can say time related characteristics associated to the given area. Very common example you can say analyzing land cover changes of satellite imageries over time for the particular area. That may be a decadal change, that may be we can say annual change, maybe monthly change, etc. And this type of information is very much useful to assess the land use dynamics, ecosystem changes, and even for the planning, even to plan the urbanization patterns for the future also. So temporal aspect, simply it deals with the temporal attributes pertaining to time related characteristics of the particular area. Text attribute measurement, again I would like to quote here, if we are talking about the text attribute, something in description here we are talking about. So here the text attribute generally involve qualitative data, not the quantitative, because text, representation, description. So here we are dealing with the qualitative data, means textual description or labels within the given area. For example, conducting any sentiment analysis of social media post, means here we are going to text. Here we are going to give the textual description. Simply conducting sentiment analysis of a social media post related to a particular geographic area. This is the must part, because here we are dealing with the area measurement. So we have to say geographic area. This is very much useful for taking the insights into the public opinions, public attitudes, and the perceptions about any events, landmarks, or about any amenities, facilities, etc. So this is the text attribute. And lastly, there is a ratio attribute. Ratio simply means we are here dealing with the numeric variables that have the meaningful zero. If in certain values, certain attributes, we find the zero has the meaning and which can be measured on ratio scale within the given area, that comes under the ratio attribute. For example, measuring the length of the rivers or streams with watershed. Within a watershed, what is the length of different rivers and streams within a particular watershed? GIS tool of field surveying techniques can be used. The length of the river segment is continuous and we know it is variable with a true 0 point. For example, absence of river length, that is what? No, 0 is having the meaning. So if the 0 is meaningful, then we can say it can be taken under the ratio attribute measurement. So this is the ratio attribute measurement. Now after having the distance measurement, area measurement, another type of measurement, third type of measurement is geometric measurement. And again I would like to say here, as the term implies geometric. So here we are dealing with the quantifying the geometric properties and characteristics of different spatial entities and the object. Simply quantifying the geometric properties and characteristics. These geometric attributes may be in terms of the length, area, perimeter, volume, angle, distance, diameter, height associated with the geographic entities, etc. Means overall here the quantification of geometric properties and characteristics is to be considered. In this we have the length measurement. Length measurement is quantified simply along the line. The length measurement will be along the line. For example, measuring the length of the river, or we can say the road segment. Simply that will be the length measurement. Then the next is perimeter measurement. If we talk about the perimeter measurement, here the measurement calculates the total boundary length of any two-dimensional shape or region, we can say. Length, breadth, we can say again length and breadth. Means here simply we are quantifying the total boundary, the length of a two-dimensional feature. For example, determining the perimeter of any land parcel or any boundary of the city, that will come under the perimeter measurement. Then we are having the volume measurement. Volume measurement is what? Simply because in perimeter we have sent two-dimensional length and breadth, only the length. So here in volume measurement, generally measurement quantifies the space enclosed by a three-dimensional object or a region. So three-dimensional, maybe length, breadth, maybe height, that will be the three-dimensional. For example, estimating the volume of water in a particular reservoir, or estimating the area, or we can say the interior space of a particular building. So this is very much useful in engineering project, construction planning, resource management, etc. Coming to the angle measurement. Now, if you are dealing with the angle measurement, as the word signifies, it determines the rotation, or we can say deviation, between the intersecting lines or planes within any geometric entity. If we are talking about rotation, deviation between the intersecting, this certain line, if we have taken this, what is the angle? This is a different angle. This will be the different angle, this will be the different angle. So actually it determines the rotation or deviation between the intersecting lines within a particular geometric entity. For example, if we take when two roads intersects, the angle formed between that two roads is very much important for traffic flow management. If the angle, what is the set criteria of the angle, through that we can say whether the traffic can flow easily or it will face some difficulty. So this is very much important, not only in network analysis but in architecture, but we can say to find out the angle of inclination of a roof slope, which is essential for the structural stability of any building. Coming to the diameter measurement, again the diameter, circle, from a point we are taking the diameter to the both the circumference. This means, so here the length of the straight line that is passing through the center of the circle or sphere, connecting 2 points on the circumference, that is what is diameter. Radius is from the center of the circle to 1 point at the circumference. But when we talk about the diameter, that is the line passing from the center and having 2 points on the circumference. So measurement determines in these terms is the diameter measurement. For example, you can see here measuring the diameter of a pipe is very much essential in determining its capacity and flow rate. So again we have to deal with the diameter here. Finally, I would like to state the height or elevation measurement. We are dealing with the height or elevation measurement, quantifying the vertical distance either above or either below to a certain reference point. That is what we can say height or elevation measurement within a particular, we can say, geometric entity. Here to quote the example, determining the elevation of a mountain peak above sea level is a representation of height measurement, or even we can say that in construction, measuring elevation of floors in a building ensures proper alignment and levelness of the surfaces. So these are the applications of height and elevation measurement. And that's all for today's class, student. Now concluding all this part, what I have discussed today in conclusion, that this measurement plays a very important role, particularly the geometric measurement serves a very fundamental tool across various disciplines, facilitating quantification of the spatial attribute. Not only this, if you have seen with, I have discussed various example and you must have found that this spatial measurement has diverse application in different disciplines and which influences the decision making processes of multiple sectors. It also enhances the understanding in terms of the spatial relationship, understanding in terms of the design and how to manage our environment more effectively. Not only this, lots of technological advancement I have seen. Maybe in the terms of, we are talking about the GIS, Geographic Information System, remote sensing, geometric measurement techniques have become increasingly sophisticated and accessible, and also it gives many times the accurate result. And finally, the continued relevance as we continue to innovate, to pioneer and explore a lot of things in our day-to-day life. These measurements remains indispensable, providing the foundation of further advancement in science, engineering and design. So that's all for today's class. Thank you. Thank you, students.